So in the last video, hi guys. So in the last video, I talked about decentralized applications and how Apple and Google actually banned decentralized applications on their app stores respectively. And today, as I mentioned in the previous video, we'll take a look at one topic. So basically what we'll do is we'll have a look at the current event, and the topic would be can blockchain actually solve data privacy and security issues, right? Um, there are a lot of articles available related to this, but what I'll do is I'll kind of comprehend all these articles, their main pointers, but importantly, we learn what blockchain is, what are smart contracts, and um, all the technical philosophies, or all the technical jargons. Will dumb it down today in such a way that we can understand, or when we read a news article from now on, we will be able to backlink these particular technical terms and understand their relevance to the article. So let's start with the first one. Let's start with what is blockchain. Right now, in the last video we saw that decentralized applications use blockchain technology. Bitcoin uses blockchain technology. Let's understand what is blockchain now. Simply, if you watch this properly, if you understand it properly, you will never have to ask anyone what is blockchain, or you won't have to read. Of course, you'll have to read it for in-depth understanding, but briefly, you won't have a problem understanding. So at the moment, let's just take a step back right now. Let's say you want to make a bank transfer to your friend, right? So there's person A, there's person B, right? Now person B sells a watch to A, right? Now B sells a watch to A. The cost related to the watch cost is, let's say, $100. Right? The cost is $100. Now, what does B do, or what does A do actually? Okay, so A says to B that I will transfer $100 into your account, right? So the second step would be B gives his bank account information to A, right? So when B gives his bank account information to A goes to his bank account app, right? Puts in the details. When he puts in the details, right, and then he sends, right? The details would cover up the name, account number, BSB. If you're doing it in Australia, you would need the branch code as well. So these three details are being put in the app by A. Now, when the details are put, right, what happens is, I'm sorry, I have to go backwards, but what happens is the fifth step. The fifth step would be bank confirms that yes, the account exists, the person exists, the BSB exists, right? And it confirms that A has enough balance in the account, firstly, to even send it to B. So all these confirmation, such as amount verification, does the receiver even have a bank account, does he have a BSB number, etc., is confirmed by the bank. So let's put it as centralized, right? So what would happen over here in an accounting sense, in the bank, is very simple. Minus A plus B. So minus A $100 plus B $100. This is the transaction information that is recorded in the bank's ledger, right? So we can't see this, it happens in the background in the bank. So this is the particular transaction that the bank will record, right? This happens in the background. So B actually goes to his bank account. He sees that, okay, I have received $100, fine, I can give you the watch, the money is coming. Now over here, what are we doing? We are relying on the bank to confirm whether the amount has been received by B, and A actually sends the amount to B. So this is the confirmation phase, but we are trusting the bank, which is a centralized authority, to do this for us, right? Now, if this is on, then why do we need blockchain, right? If there is someone already authenticating it, why do we need blockchain based information? Now take an instance where for example, Combank, just an example, right? If the Combank or if any kind of bank, let's say Bank X, right? Bank X, let's say this Bank X holds all the records in a centralized place, centralized server. So all the data related to its clients, it's held in the server. The data to its related to its clients, the transaction records, everything is held by the server. What if any hacker, is much possible, what if any hacker hacks this centralized server? Now, there can be instances where even there can be corruption at the top level, transactions can be morphed, or even it can be changed, right? So there is a place where the transaction, once it has happened, it can be changed. You can go back on the server and you can change it. I know it's the percentage of it is very minimal, but still it can happen. So the chance of it getting hacked, the chance of it getting changed at the later stage, all these kind of problems can happen in a centralized server. So what does blockchain do? Okay, now since we understand what is happening over here, right? The authentication is done by the central server, right? Now, let's have a look at blockchain. Now, if this same transaction was done on a blockchain, how would it look like? Okay, so A and B both are doing the same transaction. B sells the watch to A, right? A gives B $100. Now on blockchain, what would happen is, instead of the transaction, instead of this bank confirmation, the confirmation would be actually done on a distributed ledger. So now over here we are relying on this server to confirm, right, and record it in their ledger. But on blockchain, the confirmation would be done on a distributed ledger. Now what is a distributed ledger, right? All these terms, okay. Right? Distributed ledger. Now what is a distributed ledger? What happens over here is, there is something called as nodes. Nodes are nothing but every point of contact that is attached to the network, right? If you are using a phone and if you are connected to the network, then your phone becomes a node, right? So all the nodes, let's say there are 100,000 nodes on the network, right? These 100,000 nodes will actually confirm that A actually has the money to transfer it to B, and B actually gets the amount into the account. So you'll wonder, okay, if these nodes are confirming, so if there are 100,000 people confirming that the transaction is authenticated and validated, does that mean that they manually go and confirm? No, they don't do it manually. So this is where smart contract comes in. Now, let me rub this thing for you. Okay. Now, this is where smart contract comes in. in very simple control or conditional loops or very simple conditions in a programming language is very simple. All right. Over here as well, this programming language is used, but smart contracts actually have the code inside them, and the code is publicly visible. So you can go and have a look at the code on a public forum. You can see if this code is authenticated or not. So what does a smart contract do? Smart contract would, in this situation that we had, it would say if balance of A is less than 100, then he would print no amount in the account, right? If balance of A is greater than 100, then if the receiver's address is matched or if present, then A minus 100 and send it to B plus 100. So what would happen over here is, if A has balance less than 100, okay, the transaction has failed, you don't have enough funds in your account. If the balance is greater than 100, right, the receiver would receiver's address would be matched. Okay, does the receiver even exist? If it exists, then A would minus and send B to $100. Now, of course, before the balance is checked over here, the smart contract would also check whether A's account even exists in the network, right? So these things, this code, this is just an example. The contracts are much bigger, much more complex, much more secure. This code would be put on a chain. So what happens over here is, don't get confused. This code is actually put on a chain, and then this chain is validated by everyone. The moment 51% of the nodes say yes, it goes to 51%, or it goes to a lot of people. The moment 51% of the nodes agree in total of the 100,000 nodes, then yes, the transaction has been authenticated, validated, and this particular transaction of A and B is recorded as a chain. So this is where the chain comes in, right? Let me rub this way. So we have seen that it has to go to a lot of nodes to even record the transaction, right? Now, one transaction is equal to one chain. I'm giving you a very simple example. This is not the case. A lot of transactions actually have one chain here. One chain, or let's say when there are more than 100 chains, right, it becomes one block. Now I am using the word chain for simplicity. It would actually be a ledger. It would be a ledger of records, or it would be transactions, but I'm using it for simplicity. 100 chains or 100 transactions, when they combine together, becomes one block. And then this way, this one block is created, right? Another set of transaction, let's say this block is A. Another set of similar transaction creates block B. And when this block and this block gets attached, it is called blockchain. That is the concept of blockchain. So what we are doing here is, instead of going to the centralized server, we are saying, okay, I want to distribute it on the network. I want the people on the nodes to authenticate it for me. Then there is more trust in the network. Okay, 51%. Now you would say that still 51%. Who are these 51% people, right? Okay, so I don't want to confuse you further, because there's a difference between public blockchain or public ledger and private ledger. But on a public ledger, as soon as there is majority of transactions done, there are minus, right? Let's keep that topic for some other day. But for now, just understand this, that as soon as 51% or majority in the smart contract, there will be mentioned, as soon as a majority of the nodes that are using this particular service. So if you use this service on a blockchain, you authenticate it, you become a part of it as well. So in return of the service, you provide a service by authenticating and validating. Because if it was only receiving the service, who is going to provide it, right? So 51% of the people, or majority of the people, authenticated, and that is how the block is created. Another block created, it joins up together, it's called blockchain. Now, two concepts here, two mathematical concepts that I'll introduce to you to make it more clear. Now, when you understand blockchain, it's very, very important to understand these two concepts. One is called Merkle tree, and the second is called cryptographic hash. So forget about the second one for now. Let's just focus on Merkle tree. So what is Merkle tree basically? Sorry, I'm rubbing this out, but I don't want you to get confused by looking at the whole board at once. So Merkle tree. Now this is how a block is created. Now you understood the theoretical aspect of it. Let's have a look at a practical example. Let's say this transaction A, transaction B, transaction C, transaction D. So what we are having a look at is Merkle tree. Now if transaction A and B, they occur, so when these transactions occur, right, every particular transaction has a cryptographic hash. That is the second point which I mentioned. That is randomly generated. So every hash is nothing but like a authorization key. So every hash. Now, when these two transactions come together, and when there is a hash over here, right? If I look at this transaction, right, this particular transaction, I see this hash, there will be a hash, a trace of the hash of transaction A. So if even these two transactions come together, right, what will happen over here is this hash, I say I want to check now, is this authenticated? I can check how? I can, from this hash, I can go back to this hash. From this hash, I can go back to this hash. So basically, Merkle tree is a way of saying that, okay, transactions are happening. It is happening in a very linear manner. And I can authenticate the transaction by going back. Now, there are concepts like forking as well, but we'll leave that for some other day. Let's focus on the basic things first. So if I look at the hash over here, I would be able to recognize this transaction by going over here and by going here. So this provides traceability. So I can trace back the transaction, I can authenticate the transaction, I can validate the transactions. Now, the beauty of blockchain is every data, if there is a pool of data, this data is cut down into smaller chunks of a transaction. It's cut down into smaller chunks and it's divided between these nodes. So if there is a transaction over here with this kind of information, right, there is sender's name, receiver's name, there is hashing over there. This is divided into so small data that when it goes to the nodes for confirmation that is the transaction, is this authenticated, right, the data is divided into so small blocks that it can go to 100,000 people. They say, okay, it's authenticate, it comes back, it joins back together, and then it forms a transaction. Now, this is the concept of Merkle tree and cryptographic hashing. Coming back to the topic, right, now you understand what is a blockchain, what is a smart contract, what are cryptographic hashing, what is a Merkle tree. I will again explain this concept in my future videos bit by bit because it's tough to understand it in the first go, but I'm pretty sure you must have got a basic idea of what was the problem, how blockchain came in, and what does blockchain actually use. So blockchain is not like a technology, like it's a programming language. I'm going to use a blockchain programming language. There's no such thing. You can use any programming language in the world you want, but the authentication algorithm has to have Merkle tree and cryptographic hashing present into it, and it has to be on a distributed ledger to name it as blockchain. Coming back to data security and privacy, according to European Union's data protection regulation guidelines, they say that every individual in the world should have the right to be forgotten. So his data should be forgotten. Now the word privacy and security is being used interchangeably, but they mean two different things. Now, okay, what's the difference, right? The difference is privacy is more on an individual level. So privacy would mean that I have the right to decide what data is collected about me. I have the right to decide who the data is going to after the data has been collected, and I have the right to decide or to see what actually the data has transformed into after it has gone to someone who's utilizing my data. That is privacy. Now, if you look at Facebook's Cambridge Analytica's scam or scandal, over there it was pretty visible that Facebook's databases were hacked or Facebook didn't know what they were doing. This is where blockchain can solve this privacy related issue, because if the whole data structure was based on blockchain, I know I used words very interchangeably, but that's just to explain it in a very simple way. It would mean that anytime any user's data was given to Cambridge Analytica or it was given to any third party, the user would have the right to decide that you can give my data to the third party or not. What are you going to do with my data? And I want to see what has happened with my data. Blockchain can help us do that. But let's say you go to Amazon, you buy a book, or you go to any online store, buy some things. Centralized data can be forgotten, it can be deleted, but I'm pretty sure no one is going to do that. Blockchain, you cannot delete it. So you can't go back and delete it because it's already stored on so many nodes. It's stored on so many databases out there on the nodes that it's impossible to go out there and delete your previous data. Although I think in the future there can be an innovation in this sphere, but it will go against the concept of blockchain because blockchain should provide authenticity. It should provide immutability. Like, it should be able to say that, okay, this data has not been tampered with, it is correct. So that is privacy. Security would mean that can blockchain be hacked? So can a server be hacked right now? Yes, 100%. Can a blockchain be hacked? Yes, it can be hacked. Put it simply, one of the ways that blockchain can be hacked is by taking 51% control of all the nodes on the network. That would mean if 100,000 people are there, you take control of 51,000 computers. Statistically, even if you put all the supercomputers in the world together, still they wouldn't be able to crack the blockchain network or the Bitcoin network, because there are so many nodes connected to it, validating it. Yes, it can be hacked, but it would make it very, very tough. And as they say, nothing is perfect in this world, but we have to aim for perfection. Blockchain aims for perfection. That is where the concept of privacy, which is user related, you have the right to decide what information you can give out there. And the second is security. Can it be hacked? Can your databases, central databases, be hacked and leaked? With blockchain, a lot of the applications are actually taking use of this particular security. And what I'll do is I'll give you one example where you can start using that. If you want to use a web browser, right? The web browser is tracking your information. I would recommend you can use Brave, so Brave, Brave browser. You can download it on your Windows, Apple, on your Android or iOS phone as well. This particular browser does not exactly track your movements. It doesn't send out any information, but what it also does is it kind of gives you advertisement based on the movement of your place from one to another, so it doesn't send anything out of the computer. um, it helps you earn tokens as well. Tokens will come to it in some other lecture. But the practical application of blockchain is being used by Brave browser. So you can go ahead and try that out. It's pretty good. I tried it on the computer. Um, so wrapping up the video, I would say that of course there are limitations to blockchain. I'll cover that up again. But every revolution that has come on the internet um, is getting centralized. It was centralized, and that went against the philosophy of the internet itself, because the internet has to be a decentralized network. Blockchain aims to decentralize the internet network. Also, what I'll be doing is I'm not creating any Facebook page for now, or any groups for questions, but I'll put my email ID down in the description. So if you have any questions specific to the video, or if you think that you need a bit more explanation on this, you need another video for this, I can do a series 2 as well. But do let me know through my email. All right, thanks for your time. Cheers.